If someone deleted all of your VM templates right now, how long would it take you to rebuild them? Do you know who has powered on your VM templates and exactly what changes they've made? Are you 100% certain that your VM templates are consistent between your dev test and production environments? If you're already building your VM templates programmatically, then this is no big deal. There's no question as to how your VM templates are configured in each environment because they're described in code. There's no need to waste CPU cycles, bandwidth, or storage capacity anymore on backing these up, because if something happens to one or more of your VM templates, you can build exact duplicates in just a few minutes. When you're doing this right, you'll never power on a VM template again to update it. Instead, you'll build replacements whenever you need to make a change. Hi, I'm Troy Lindsay, and today we're going to start off with an overview of HashiCorp Packer. We'll dive into some Windows Server and Ubuntu Server examples, and then we'll check out a brief demo and the associated code. All of the code for the examples are available in a GitHub repository, and I'll share a link for it at the end. If you're worried that you need to be a software developer to understand this stuff, don't be. If you can read and update config files and shell scripts, then you can learn this too. If you're already familiar with Packer, then there should still be some new things for you to learn, because all of the examples are written in the newly supported HCL2. We'll also take a look at Ubuntu's new automated installation system, Ubiquity, and I'll show you one way to build a Windows Server image with the VMXNet3 network adapter and the Paravirtual SCSI controller without building a custom ISO. But we'll get to all that in just a bit. So what is Packer? It's an open source infrastructure as code tool that automates the creation of machine images in a variety of environments, such as Amazon EC2 and VMware vSphere. You can use it for most operating systems such as Windows, Mac OS, and Linux. Using tooling such as this, you can achieve consistency and disposability for your VM templates. These ideals are important because they help you deploy changes faster, reduce the amount of time that you and your team are spending troubleshooting, and recover from failures quicker. When your VM templates are described in code, you automatically have the documentation for them. This makes it easier to help new team members ramp up quickly. Another key benefit is that skills like these are in demand right now, so invest in yourself by learning them because many organizations have already started realizing the benefits and are looking for more people who understand them. I mentioned at the beginning that examples such as the screenshot shown here are written in HCL2 instead of the traditional JSON. If you're not familiar, HCL2 is short for HashiCorp Configuration Language version 2. We're doing this for a few reasons. First, HashiCorp intends to replace JSON with HCL2 as the default configuration language for Packer going forward. So why not learn the latest and greatest? Unlike the original JSON implementation, HCL2 supports variable descriptions and comments, so you can add context to your definition files and help others understand what you built and how to use it. If you're already familiar with HashiCorp Terraform, this will look familiar because HCL2 is also the default configuration language for Terraform. If you're not, Terraform is another great tool that pairs well with Packer. And if you're interested in learning more, I cover it in my next session, CODE4234, Building Hybrid Solutions with VMware, AWS, and Terraform. So what are the key components of Packer? There are 4 key components to a Packer definition file: variables, builders, provisioners, and post-processors. Variables allow you to customize your build without changing the code. When you're doing this right, you can use the same config file to deploy a new set of VM templates in both your dev test and production environments, and you only need to change the values of a few variables to do so successfully. Builders specify where to store your VM template in vCenter, how it should be configured, such as the vCPUs, RAM, and virtual disks, as well as the instructions for automatically installing the guest operating system. Of note, Packer supports specifying multiple builders in the same definition file, but I don't recommend doing this because it's easier to support config files when they're concise and specific. Once the guest operating system has been installed, you can use provisioners to upload files or run scripts and commands to configure the VM or install software before powering it down to convert it to a VM template. Last, I rarely use post processors, and they aren't used in the example code that we'll look at today, but you can use these to run additional steps after the build completes if necessary. User variables are what you'll use for the most part for configuring your builds. There are three main user variable types: string, number, and bool for true false. There are also complex types such as lists and maps. Lists are collections of values, such as the list of files to mount via the virtual floppy disk drive. And maps are just groups of key value pairs. You can set default values for your user variables. You can also set the values in another config file, on the command line, or with environment variables. The example repository doesn't showcase this feature, but you can also load values for your user variables at build time from HashiCorp Vault or AWS Secrets Manager. Local variables are great for formatting the values of user variables. For example, I append a timestamp to the VM name so you know exactly when your VM template was built, and this prevents name collisions for subsequent builds. On that note, it's a good idea to replace your VM templates regularly to incorporate the latest patches and test your automation. And last, Packer comes with a few built-in variables for providing information about the build engine. I didn't use build variables in the example code, so I used Lighttheme here to distinguish that you won't find this in the repo. Next, there are 4 official VMware builders in Packer. 2 ISO builders are for when you want to build from scratch, which is the best way to build for almost every use case. VMX and clone builders are for when you want to iterate on an existing VM template. One good use case for this is when you want to add a few customizations to a third-party virtual appliance and template this. VMware ISO and VMX builders were the original set. One limitation of these is that they require SSH connectivity to the hosts. vSphere ISO and clone builders were added later, and I prefer them because you don't have to enable unnecessary connectivity to use them since they use the vSphere API. In the demo today, we'll only use the vSphere ISO builder for building our VM templates from scratch. There are a bunch of different types of provisioners available for configuring your images and installing software after the guest operating system is installed, including integrations with popular configuration management tools such as Ansible, Chef, Puppet, and Salt. We'll only use the 2 most common provisioners today, which are PowerShell, which is used for running PowerShell scripts as the name implies, and Shell, which is used for running most other shell scripts. In either of these, you can set the commands as an inline script, you can run an individual script, or you can run a set of scripts. My personal recommendation is to only use the scripts option. Most people tend to configure their various machine images similarly, so using inline scripts requires duplicating changes across multiple definition files consistently. Using external scripts helps you reuse code, which saves you time. And I prefer the scripts option even when I only want to run one provisioner script because it's the easiest to maintain. When you use the script option and need to add another provisioner script later, you either need to update the provisioner configuration or add another provisioner script block. This adds unnecessary complexity. Now that we've covered the basics, here are the 3 VM templates that we're going to build today. Again, we'll be building these in a VMware cloud on AWS Software Defined Data Center, or SDDC, but these should be usable in most VMware environments with little to no updating. Of note, these VM templates are not production grade as is and include no hardening, but could be iterated upon to get to that point if so desired. First, we'll build a Windows Server 2019 Data Center Edition VM template. Next, we'll build a new Ubuntu server template with Subiquity, Canonical's new automated server operating system installer that's based on Cloud.inet. Cloud.inet is now an industry standard for instance initialization, such as in Amazon EC2, and it supports most popular distributions of Linux and BSD. One big limitation of it, though, is that it isn't interoperable with VMware's guest customization system. If guest customization is a requirement for your environment, keep using the Debian pre-seed system for your Ubuntu server images for now. Last, we'll build a new template with Ubuntu's Debian pre-seed system, which Canonical has deprecated. This has been around for years, so there's lots of open source examples and blog posts available for reference. Now let's kick off our builds, as these will take a few minutes to run. The console output of Packer isn't all that interesting, and neither is the OS installation process. So let's take a look at the code once these are running. We'll take a look at the code once these are running. Well, we'll start with the Windows Server build, since it takes the longest of the three, and the patching instructions have been disabled to minimize build times for the demo. Here's the command for starting the build. It's just packer build and then the file name, windowserver.packer.hcl. So pretty simple. I've set a few environment variables to configure the build, such as the vCenter and local admin passwords, and I'm not going to show this for obvious reasons. Once started, the VM is created in the specified location in vCenter. The ISO image is mounted, and the guest operating system installation process commences. So the installation process is automated via a config file named auto1attend.xml, which I presented to the VM via a virtual floppy disk. This config file, which we'll take a look at in a minute, provides the installer with all of the necessary instructions for installing the OS without any user input. And in a few minutes here, we'll have a brand new Windows Server 2019 Data Center Edition VM template, and that's all there is to it. And here's our Ubiquity build. So again, real simple, Packer build, Ubuntu server.packer.hcl. Both Ubuntu server builds include a little boot command script to tell the installer where to find the config files, which in both cases are also loaded via the virtual floppy disk. Well, we'll take a look at the Ubiquity, Cloud Init config files in just a few as well, but first let's start our Debian pre-seed build. And here, I wanted to showcase a little something different. I've also included a variable config file. This one's called lamp.packervars.hcl as a way to showcase reusing code. So it's going to alter our build just a little bit. It'll change the VM name, and it will specify a different pre-seed file, as well as it'll specify a different pre-seed file, and it'll tell the OS it'll tell the installer in the boot command where to find it. So here's our little boot command script that's updating the options here. But yeah, even though there's a different boot command script, the installation process is very similar. Now that we've started our three builds, let's dive deeper into how we've configured our Windows Server build. First, we'll take a look at the auto1attend.xml file. Like most XML files, this is not easy to read, but luckily that there's a tool that allows you to, that makes this a little bit easier for configuring it. It's called Windows System Image Manager. As you can see, it's not much better, but it does allow you to explore what options are available. It tells you which settings have constraints, such as length limits or a set of valid values. It has built-in config validation, and it will mask the local administrator password in the config file for you. This provides limited privacy, so be careful where you store copies of it, because those with the tools and know-how will be able to decipher the password. On the other hand, anyone can reset the password in VMs deployed from the VM template via guest customization, and that they don't have to know the original password. So it isn't all that important. So I have everything configured in 3 of the 7 available sections in the auto1attend config file. In the Windows pre-installation environment section, or Windows PE, we configure everything we have everything needed to automatically install the OS. We set the default language and locale. We tell the installer where to find the VMware Paravirtual SCSI controller driver. We partition the system disk. We tell the installer to install the OS on disk 0, partition 2. We specified that we want Windows Server 2019 Data Center Edition. And we accept the EULA, or the End User License Agreement. Next, in the Specialized section, we install VMware Tools in Quiet Basic mode. So no input, just shows a progress bar, and it'll reboot afterwards. When it comes back up, we enable terminal services for remote management of VMs deployed from this template. And we disable the host-based firewall. Well, we do this because in VMware Cloud on AWS, where we have the NSX gateway and distributed firewalls that are easier to manage at scale. Next, in the OBE system section, or out-of-the-box experience section, we set the local administrator password, and we set it to automatically log in one time with the administrator account. And once it's logged in, we initialize WinRM over TLS. And this starts the provisioner process. Now let's take a look at the config file. So here's the Packer config file. Most people specify their variables at the top, the user variables at the top, but you can define them elsewhere in the file, and Packer will figure it out. Here's the VM version for the virtual hardware version. We use 17 here because VMware Cloud on AWS supports the latest and greatest, but you can override it. Here's our local variable section, where we append the timestamp to the VM name. Next is our builder section for the vSphere ISO builder, where we specified the VM geometry, as well as where to provision it in vCenter. And last is the build section. This is where we map our builder and our provisioner scripts. Here, I'm running a few PowerShell scripts with elevated privileges. The first one here resets the auto logon count in the registry to ensure that it doesn't automatically log in again after the build. And next is installation of Windows updates. I have it commented out so, that the build runs a little bit faster during the demo. Then we install Chocolatey, which is a CLI package manager similar to Ubuntu's apt. Then we install the Windows OpenSSH server package. And we install the AWS CLI via Chocolatey. Now, none of these provisioner scripts are necessary. I just wanted to showcase what you could do with the build and give you some ideas of how you could configure things. Now let's take a look at our Ubiquity build. The user data file that defines in YAML format how the guest OS install should be configured. Here we we set a few basic things such as the default language and locale and the storage layout. Ubiquity supports both a direct and LVM layout, and I've chosen direct here. Next, we create our user account and set the password. when you want to generate your password, this is what it looks like. So you'll use the mk password command, and for the CloudInit documentation, use the SHA 512 hashing algorithm with at least 4,096 rounds of salting. And if I run it again and enter the same password, it'll actually come out with different results. So it'll be unique every time. But again, this provides limited privacy, so be careful where you store it. Next is the metadata file. For vSphere builds, this will be blank. The metadata file is used in CloudInit for configuring instance-specific details at the cloud provider. So it is required, but it should be blank for vSphere builds. Now, here's our Ubuntu server config file for Subiquity. There's a few different values, and some of the same values have different defaults, but the boot command is a new one. And then down here in our builder, one thing that's unique about CloudInit builds is that you have to label the media that where the user data and metadata file live for configuring the build, and it has to be labeled CI data. Down here at the bottom, we specify our builder and a shell provisioner script. So just one in here. We install at the AWS CLI via Python 3 pip. And we also use this in our Debian pre-seed build. So that's one way of showing code reuse. Now let's take a look at our Debian pre-seed build. So first, here is our lamp.packervars.hcl variable config file. This is another example of how you can reuse code with Packer. The settings here tell the build to mount a different pre-seed config file to the virtual floppy disk, where to find this file for configuring the OS, and what to name the VM template. Next, here's the pre-seed file that we're going to use. And even though it looks quite different, it's configured almost exactly the same as the Subiquity build. Two small differences are we installed the LAMP server package and the NFS common package. And that's it. Last, here's our Debian pre-seed build. Config file, and it's pretty similar to the Subiquity config. Again, so some of the values have different default values, such as this one right here, but otherwise it's pretty much the same. And I don't specify the floppy label because it's not necessary, since this is not a CloudInit-based build. So let's go back to vCenter. Looks like all of our builds are complete. So in just a few minutes, we built 3 brand new VM templates. And here's a little PowerShell script that I wrote to deploy a VM from each VM template. That'll go here in just a second. So while we're waiting on that, does anyone have any questions?
I do see a question for you, Troy. Do you have to do anything special to get Packer to work in the VMC on AWS environment? I had troubles with this a few months ago when I wanted to explore Packer, so I ended up giving up. Might revisit, as you appear to be doing just fine.
Yes, it does work just fine. with VMware Cloud on AWS, since it is a managed service, there are a few different there are a few managed resources that you can't change, but as long as you specify to um, where, where to deploy the VM template in one of those managed resources or underneath them, it should be okay. But yeah, happy to help with that. Feel free to hit me up on Twitter. Or via the repo on GitHub. I have my Twitter handle there. But yeah, happy to help with that. Anyone else?
That is the only question that I see so far.
All right. Well, thanks for joining today. I hope that you found this session valuable, and please remember to fill out the survey afterward. My next session, CODE4234, Building Hybrid Solutions with VMware, AWS, and Terraform, starts at 1:30 p.m. Pacific Daylight Time today, and I hope that you join me for that one as well. Thank you.
Thanks, Troy.
Thank you.
Bye.